This video will cover this particular question here. How many years will it take $7,000 to grow to $11,400 if it is invested at 9%, I'm assuming that's an annual rate, if it is A, compounded quarterly, and B, compounded continuously? So let's start off with compounding quarterly. The equation governing that is going to be the following. A, our future value, is going to be equal to our present value times the quantity 1 plus your interest rate expressed as a decimal divided by your compounding rate raised to your compounding rate times the time. And what we're looking for is indeed the time. Now, since we're compounding quarterly, our compounding rate is going to be 4. There are 4 quarters in a year. Your present value, the amount that you're putting in, that will be P. That will be equal to $7,000. The amount that we expect to have in the future is $11,000. That is our future value. Actually, $11,400. And our interest rate is 9%. However, we cannot work with percentages. We need to convert that to a decimal. That is equal to 9 divided by 100, or 0.09. Making the substitutions, we have A, which is $11,400. This is going to be equal to P, which is $700, times the quantity 1 plus 0.09 divided by 4. And that's going to be raised to the 4t power. Okay, well, the first thing that we can do is you can divide both sides by $7,000. And if we do, these will cancel, and we can use our computer calculator to figure out what we're going to get on the left-hand side. That is going to be 11,11400 for the 400 divided by 7,000, and that will give us 1.62857. We're just going to round that to 1.62856. That is going to be equal to 1 plus 0.09 divided by 4. That will be raised to the 4t power. Now, 0.09 divided by 4 is equal to 0.0225. So this will become 1.62856 is equal to 1 plus 0.0225 raised to the 4t power, and that will simplify to the following. This can simplify, we can combine these two together, and this will simplify to 1.62856 is equal to 1.0225 to the 4t power. We can now go ahead and take the logarithm, and let's go ahead and do the common log, log, for both sides. So that's going to be log of 1.62856 is equal to the log of 1.0225 raised to the 4t power. Using the power property of the log, we can write this as 4 times t times the log of 1.0225, and that will be equal to the log of 1.62856. I can now divide both sides by 4, and this particular log here, log of 1.0225. So we're going to do that here. And of course we had to do the exact same thing over here to maintain the equality. So 4 times the log of 1.0225. Of course these cancel, These cancel. We will have the log of 1.62856 divided by the quantity 4 times the log of 1.0225 is equal to t. And this we can compute on our calculator. Notice log stands for this button right here, so I'm going to hit log 1.62856, close parenthesis, divide. Now since we have two terms in the denominator, we need to start with the parentheses so we can combine those two terms. Then we will have 4 times log 1.0225, close that parenthesis, close the second parenthesis, and hit enter. And we get 5.479 years. We get that t is equal to 5.479 years, and I think we're going to want this at 2 decimal places, so this will round to 5.48 years. Okay, what about the second part where we're compounding continuously? Well, if you see the two words compounding continuously, then the equation that needs to come to mind is this: A is equal to P times E to the RT. Okay? And once again, we know what A is. A is $11,400. We know what P is. P is $7,000. And once again, we know what R is. R is 9%, which maps to 0.09. And once again, we are trying to figure out what t is. Well, we can go ahead and make our substitutions, and if we do, we are going to have $11,400 is equal to $7,000 times E times 0.09 t. Now we want to proceed the exact same way we did before. Specifically, we want to divide both sides by $7,000 to get rid of the coefficient next to the E. And if I do, these will cancel. Over here, I will have 1.6286, and that will be equal to E to the 0.09 t. Now I can go ahead and I can take the natural log of both sides. And why do you want to compute the natural log? Well, the natural log is a log base E, and it will make this computation a lot easier for us. Now, if we take the natural log of both sides, we're going to have the natural log of 1.6286. That's going to be equal to the natural log of E raised to the 0.09 t power. Okay? Once again, we can use the power rule here, and if we do, or the power property, and if we do, we will have that this is equal to 0.09 t times the natural log of E. And over here, we will have the natural log of 1.6286. Okay, now this is why we're going to use the natural log. The natural log of E right here is equal to 1. So this becomes a coefficient of 1, which means it can go away. And what we're left with is the natural log of 1.6286 is equal to 0.09 times t. And if that's the case, t is going to be equal to the natural log of 1.6286 divided by 0.09. And let's see what that looks like on our calculator. So once again, we're doing the natural log. That's ln, so we're going to click this right here. And that will be 1.6286, close the parenthesis, divide 0.09, and that gives us a value of t of 5.419, which will round to 5.42 years. And that is all I have for this little video. If you have any questions, please feel free to contact me. This is Bob Boyle signing off.